Okay, let's start. So today we are going to basically learn how to write these two very important functions for any class. One is the constructor function and the other is the destructor function. Now, why do we need to write the constructor and destructor functions? So if you remember, like last time we created these classes. We wrote this class in our last session. And in here you can see like the my time class has these three data members: hours, minutes, and seconds. And if for example, like you create any object of this type and we do not call this reset function and we just like print it directly, so we witness that the data members have garbage values. Now that is something that we don't like. Okay? Whenever you create an object, the data members should be properly initialized. And not just, this is a very simple class and this object has these three very simple data members. Sometimes you might be required to create classes which might need to connect to a database or to a web server, or which might need to open some file or something like that. So if that is the case, then you need to make that connection. Whenever an object of that class is created, you need to make or establish that connection before something else can be done. Now you can do that as part of your constructor, or you can do that as part of some other function, but then that other function must be explicitly called by the user. So say for example, in the main program, if we forget to call the t.t1.reset function, then the t1 object will end up having garbage values in its data member. So constructors provide you with an automatic mechanism wherein the data member will automatically be initialized. You don't need to explicitly call a constructor. Whenever you create an object of a class, or whenever you instantiate an object of a class, for example, whenever we say my time t1, the constructor will be automatically called by the compiler. So it will invoke the constructor automatically. So there will be code for that. You won't need to provide it. You just whenever you say my time t1, the constructor for my time class will be automatically executed, and the initialization of the data members of the t1 object, that will be carried out automatically. Now how do you write? So this is basically the purpose of writing constructors. Why do you need constructors? Because you need to initialize the data members of a class to their appropriate values, appropriate initial values. And then we talked about the destructor as well. Now destructor is also very important. Why is it important? Because again, as I said, whenever an object of a class is created, it might require to reserve some memory for something, it might require to open some files, it might require to make some connection with a database or a web server. So when that object is removed from the memory or destroyed, we need to close the file, we need to close that connection that it made to the database, and we need to close its connection to the web server as well. Why do we need to do that? If we fail to do that, then for example, if we fail to close an open file, then that file may not be usable by any other application. So whenever one application opens a file, the file is locked by that application. No other application can modify that file or delete that file, something like that. So if another application wants to access that file or use that file or make changes to it, then the first application must release that file. Okay. Now if you happen to write classes that need to access some file on your hard drive, then in that particular case, when you open the file for that object, it must close that file. Okay? And similarly, we talked about yesterday we talked about the heap memory or the free memory. So whenever you reserve memory on the heap, so you do that explicitly using the new operator. Okay? And that memory that you reserved for yourself or for any purpose, it will remain reserved unless you explicitly release it, unless you explicitly delete it. Now, if you happen to use memory on the heap in one of your classes, then you must do that explicitly. You must reserve it explicitly, and you must release it explicitly. And these two activities happen in the constructor and destructor automatically. So whenever an object of a class is destroyed, the destructor will be called automatically. You don't need to call it explicitly. So whenever the object is destroyed, the destructor will be invoked automatically, and it will do this finishing job, like whenever that object is destroyed. So if it has to close file handles, it will close file handles. If it has to release memory on the heap, that will also be done. Okay, so that is the purpose of constructors and destructors. So let us see how can we write a constructor. So in order to write a constructor, like again you need to specify it here in your class declaration, and we need to write the code for it as well. So how does the constructor function look? Now the constructor is a special function. Okay? Constructor is a special function in C++. Whenever you want to write a constructor, so the constructor has the same name as the class. So if this class is myTime, so its constructor would be myTime. Okay? It will not have any return type. It will not have, you don't need to say like void or int, or it is basically going to return a myTime object. So that is what you need to specify. And since this is a function, so it will receive some arguments. Okay? So this is how a constructor might look. The constructor is a function, okay? And it is going to be a block of code, and its name is the same as the name of the class. Its name is the same as the name of the class. This constructor, which does not take any or receive any arguments, this is called the default constructor. Sorry. This is called the default constructor. G? Why doesn't it have any return type? It has, you can say it has a return type, like it returns an object of myTime, type myTime, but you don't explicitly specify it. So this is the requirement of the syntax for declaring the constructor. In C++, you name the constructor as the name of the class. In some other languages, it is different. For example, in Visual Basic, I guess it used to be new. So the constructor function used to be new. It used to be called new. Okay? It doesn't need to be named as the name of the class, I guess. So in different languages, the syntax for creating the constructor is different. In C++, you create a function that has the same name as the name of the class, and it is a function. That is the only difference. Okay, so this is your default constructor. Okay, so you take it as if this is the required syntax that you need to follow. Now the default constructor. Why is it called a default constructor? So even if you don't provide any constructor, the compiler automatically provides this constructor. The default constructor and the destructor, they are automatically provided by the constructor. They are, the compiler. They are provided by the compiler, but they don't do anything useful. Okay, so, but they are there. You can assume that they are there. And they will be called and executed, but they don't have any code. Like you didn't write anything for those constructors. So that's why they don't do anything like visible to you. They don't initialize the data member. They don't do anything else. But this is a dummy default constructor that is provided. Yes, there must be constructors. So code for classes. When you are writing your classes, when you are defining your classes, you should also define the constructors for those classes. That is the point. Okay? So why should you do that? Because you want the data members to have some initial values. Whenever an object of that class is created, you want the data members to have some initial values. Okay? And we'll also see, like, we can create more constructors, like we can overload the constructor. Okay? What do we mean by function? You should know what is function overloading. What is function overloading? Yeah, functions that have the same names but different types or number of arguments. So those are overloaded functions, and the ability to create or write these overloaded functions, that is called function overloading. So you can overload the constructor as well. Okay? This is the default constructor. The default constructor does not require any input arguments, but you can overload it. For example, we can create a constructor where we can specify values for all these data members. Okay? So we can do that at the time of instantiating the object. So this would be an overloaded constructor. This would be an overloaded constructor. Okay. And here we are doing something that is called function overriding. Function overriding. Okay. What do we mean by that? So we are overriding an existing function. We said that this is the default constructor. If it is the default constructor, it must be available by default. Okay, and it is available by default. So, but it does nothing useful. It is just a dummy function that is, say, assume that it is executed whenever you instantiate an object, but it does not do anything useful. To make it useful, you override it. You provide your own definition for this function. So this is function overriding. You will do it extensively when we go and study inheritance in object-oriented programming. Okay. So in inheritance, what we'll be doing is we'll be deriving new classes from existing classes. Okay. And when you derive new classes from existing classes, in the new class, you might want to do some existing activity or method differently. Okay. So then you will require function overriding. Okay. So we'll talk in detail about it later on. But function overriding is that if you have one function, already there is a function, but you don't like the way it operates, and you want to change that, or you want to improve its performance or efficiency or anything like that. So what you do is you override it or change its implementation. A very simple analogy can be like all cars, they have this fuel injection system. Okay, that injects fuel into the engine along with the air. So air fuel mixture is injected into the engine. So say for example, Mehran, it's a very simple car. So nowadays it also comes in EFI, the ones that are, but before say 2011 or 12, Mehrans, they used to have a carburetor based fuel injection system. And after that they have EFI, electronic fuel injection system. Okay, so fuel injection, that functionality is there, but the way it is done, that has been changed. So it has been overridden in the new version of Mehran. Say for example, brake. So the interface for the brake in any car is the same. You press the brake pedal. But in some cars you will have an ABS. In some cars you will have an ABS and electronic brake force distribution, EBD as well. In some cars you won't have any ABS or EBD. You'll just have a simple hydraulic or pressure brake kind of thing. Okay, so the interface is the same, but the implementation is different. That is kind of overriding. In the later versions of any new object or product, the previous functionality is overridden, new technology is used. So that is basically function overriding. That is how you can make sense of it. So we declared that we are going to have two constructors, and let us now write these two constructors. Okay, so how would you write? You will write these constructors just like any other function that you write. So let us go to our implementation, and here we want to provide definitions for these classes, these functions. So this is the constructor function of myTime class. So we need to specify that explicitly. Okay, so we are specifying the name of the class and the scope resolution operator, and this basically tells the compiler that this is the constructor function of the myTime class. Okay. So this is the default constructor, and this is going to be our overloaded constructor. Here again we'll specify So this is our overloaded constructor. Now we haven't written any code here, but here this is the body of your constructor function, and here you can write whatever code is necessary to initialize the data members properly. So for example, in the default constructor, what we want to do is we want to initialize all the data members to say zeros. Okay, so we want to say hours is equal to 0, minutes is equal to 0, and then we want to say seconds is equal to 0. Okay, so this is the initialization that we want to do here. And let us print this message as well. You shouldn't be doing this whenever you're writing your code. I'm doing it because I just want to let you know, like, the default constructor has been invoked. Okay, the default constructor has been invoked. So whenever we see this message being printed, that means this code has executed. Okay, so let us do that. We are not going to call the reset function. Let me comment this code out. Okay, so right now we just want to focus on constructors. So we don't want this code to be there. So whenever I say my time t1, so the constructor, the default constructor will be called. Okay. If we say again my time t2, the default constructor will be invoked again. So for each object that you instantiate here, the default constructor will be invoked. If you are instantiating 2 objects, it will be invoked 2 times. If you are instantiating 2000 objects, it will be invoked 2000 times. Okay, and we can see the effect. So you'll see that message printed on the console screen that the default constructor has been invoked, and you can also see its effects. So now if you print this object, the data members will be initialized to 0, 0. Okay? All data members will be appropriately initialized. So if we build and run this code, so you see this message printed twice. Default constructor has been invoked, default constructor has been invoked. So why is this message printed? We wrote the code for printing this message in this function. This is the default constructor. Okay, so we didn't explicitly call it. Like, we never wrote any call to that function here. But just by instantiating an object or declaring an object or defining an object of this class, we are basically invoking the constructor function. Okay. No, it doesn't act like a loop, but just how are you like relating it to loops? No, it is repeating because you are making declarations, more declarations. So if we don't do it, so if you are just creating one object, so it won't do that. So you'll get it. The point is, if you are creating one object of a class or 10 objects of a class, for each object of the class, T1 and T2, they exist separately in RAM. Okay? So for each object of the class, its data members must be initialized properly, and that is done by calling or invoking the constructor function. So it depends upon the number of objects. It is not like all the objects share those data members. Each object has a separate copy of those data members. And whenever an object is created, so those data members need to be initialized. Okay? That is why it is called as many times as you as many times as you create these objects. Okay? So if you are creating 10 objects, it will be invoked 10 times. And this is done automatically. Now what if G? Yes, so say for example, at times you might want at the time of declaration, I should be able to specify the values for those data members. You can do that as well. Say for example, here, let us create another object. We want to say my time T3, and at the time of declaration, we want to specify what should be the hours, minutes, and seconds for T3. So say for example we say 12, 10 and 30. Okay, so you can do that here. Now this will invoke the overloaded constructor. This will invoke the overloaded constructor. Achha ji. Let us come here. Right now we haven't written any code here. Okay? So let us do that. In fact, since we have written these hours function and minutes function in there, we can do validation as well. So let us use those functions. So if I get hours as input, so I'm invoking the set hours function, okay, and I'm passing it h to initialize the hours data member, and then I'm calling the set minutes data member function, and I'm passing it m. Why am I doing this? Like, you can do it directly here, but since I have written this validation code in these functions, so I want to reuse that code. Okay? It will make it like, it will take some time, but nevertheless it is useful. Okay. So, and we want to print this message, overloaded constructor has been invoked. Okay, so that you know. Now you shouldn't be doing this. Like, I'm doing it because I want to help you understand it. So overloaded constructor has been invoked. Overloaded constructor will be invoked once, and the default constructor will be invoked twice. Okay, and here you specify. So now you are basically specifying when you are providing these input arguments. So you are basically specifying which constructor do you want to invoke. Here you did not provide any arguments, so the default constructor will be invoked. Okay. Now if you build and run this file, we did not print T3, but in any case, so default constructor has been invoked, default overloaded constructor, and we did not print T3, so that's why you don't see that output. If you say something like this here, T3.print, so then you will be able to see the value of T3 as well, appropriately initialized, just like you specified in the main function. Okay. So this is the overloaded constructor. So you should be able to write the default constructor, and you should be able to write the overloaded constructor. You should be careful with, you should keep one thing in mind. If you provide any constructor, an overloaded constructor, if you provide an overloaded constructor and you forget the default constructor, for example, so the compiler will not provide the default constructor then. If you do not provide any constructor, the compiler will provide the default constructor. If you provide one constructor, any constructor, okay, whether it is default, whether it is overloaded, then the compiler will not provide any constructor. Okay? Now this can be problematic. Let me verify it. Let us verify it. Say for example we get rid of this default constructor. Okay? And here too we basically comment it out. Here too we comment it out. So now we don't have the default constructor. What we do have is the overloaded constructor. So what will be the effect of these actions? So let us see. If you do not have the default constructor, you cannot make declarations like these. Okay? This is fine, but now you cannot make a declaration like this one. Okay? Because this invokes the default constructor. And since you wrote one constructor, so the compiler is now like free of worries. The compiler knows that you have taken the charge, and now you are going to write all the constructors. If you do not provide any, the compiler will provide a default constructor. Okay? So here you say, you get this error, no matching function for call my time. So the default constructor, there is no default constructor. Okay? This did not happen when we did not have any constructor. It didn't happen. Okay? Because then the compiler was providing you with the default constructor. But now that you have provided the overloaded constructor, so the compiler is not going to provide any constructor. So if you're writing if you want to like write or provide your own constructors, you must provide the default constructor. Otherwise, declarations like these will not work. Okay. G, question. If that is the case, like you're sure you're never going to need this declaration, fine, then it won't create any problem. But usually we do not have that much control on the user. So you are going to think about it from the perspective of somebody whom you do not know. You're writing a library and anybody can use it. So maybe they would want to use it this way. If you do not provide the default constructor, you are basically restricting the usage of your library or class in some way. If that is absolutely necessary, like you do not want, like if somebody uses it in this format and that can lead to some problem, then that is fine. But if that is not the case, then you should not be limiting your potential user. Okay? Yes. Yes, that is the point. The point is not if it is about sequential or non-sequential execution. Execution is always sequential. The point is we provided one constructor, and that is the default the overloaded constructor. This one. So this constructor is there. The default constructor is not there. We did not override the default constructor. Okay? We just provided the overloaded constructor. See, so I commented out the default constructor. Now, if you provide one constructor, and that is the overloaded constructor, the compiler will not automatically provide the default constructor. Then you don't have the default constructor. Okay? And if you don't have the default constructor, you cannot invoke the default constructor. Declarations like these invoke the default constructor. If you don't provide any constructor, okay, you comment out this one as well, like just like the way we had before. We did not have any constructor. Then the compiler provides you with the default constructor. So you did not write it, but the compiler writes it for you. It does not do anything. It is a dummy function, like it does not have any body, but it is a function there because the compiler has to follow the sequence. If it is creating an object, it is going to call the constructor function, and there has to be a constructor function to be called, so it gives you the default constructor. Okay? So the point that I want to make it here is that if you choose to write your own constructors, then you have to be careful. You have to provide implementation for the default constructor as well. If you do not do that, you should not assume that the default constructor will be there just because it is the default constructor. The compiler will not provide you with the default constructor if you choose to write your own constructors. Okay? That is the point. So ideally, like you should have this constructor. Okay? You should always have the default constructor if you want to do something like this, like if you want to create or instantiate objects by not providing any input argument, and people might want to do that. Okay? So you should be careful about that. There's another thing that you should remember about constructors, and that is constructors must always be public. Okay? So constructor functions must always be public. Say for example, if I move this constructor function here, okay? So now it is here. By default, its access specifier is private. I have moved it out from the public space. So now we have problem. Okay? Now the default constructor is private. It is not accessible by any other program. So if you want to compile this code, so you will get an error. Okay? So this function, the default constructor is private, and you are invoking it from the main function. Okay? So you should be careful about these two things. Okay. Another thing like that should be clear, I guess. You can have many overloaded constructor. Like you can have an overload constructor where you just specify the value for the hours. You can have an overload constructor where you just specify the value for hours and minutes. Okay. And you can have an overload constructor where you specify values for all three. So you can have all these variations. Okay. I'm not going to write bodies for these functions. You can write these later on. Maybe you can do it as part of your lab to practice this some more. I want to talk about something else. Now, you see, like we have this object T3, and we initialized its data members with these values by invoking the overloaded constructor. There is another way of initializing the data members of any new object. Say, for example, we want to create another object T4. Okay? So you can say my time T4 is equal to T3. So we are basically creating a copy of an existing object. So my T4 would be a copy of an existing object T3. So if you print T4, if you say T4 dot print, okay, so it will basically be a copy of T3. Okay? This is another way of creating an object and initializing its data members. Now, how does this happen? Behind the scenes, there is another constructor function that is being invoked, and that constructor function is called the copy constructor. That is called the copy constructor. You can also instantiate an object like this. Again, we'll be invoking the copy constructor. Okay? So you can say my time T5, and then you can say T3. Okay? So now we are explicitly passing an object, already existing object, as an argument to some constructor that we didn't write. Okay? So we did not write any constructor that accepts an object of type my time. We didn't write it. But that is also provided by default by your compiler. So the copy constructor is there. Now copy constructor is important. Like you should be able to use this assignment operator. You should be able to copy one object into another object, or you should be able to return an object of this type from some function, and that object, when it is received by the main function or any other function, so its data members should be able to, you should be able to copy those correctly into the other object. In any case, if you write statements like this, if you assign one object of my time to another object of my time, so what happens is there is a member-wise copy between those two objects. So the data members of T3 will be copied into the data members of T4. Similarly here as well, we are invoking the copy constructor. Here we are basically invoking the copy constructor. The copy constructor is provided by default, and it is not just a dummy function. It does the member-wise copy, and it does that correctly. Like you can see, if you print T4.print, you will get the correct value for T4. It will have 12, 10, 30 as its data members. If you say T5.print, again you will get those same data members because it is also based on T3. So the copy takes place correctly. The copy constructor is not just a dummy function. It has, you can assume, some code in there which ensures that there is a proper member-wise copy. Okay. So right now we will call that as a shallow copy. Okay. Later on, when we learn some more things about object-oriented programming and pointers and the heap memory, we will talk about the limitations of this shallow copy. So then we will say something or do something like a deep copy. Okay? So, but keep that in your mind. We'll come back to that later. Now let us see what happens in this code. So if we build and run it, so you will see this output. Now this output, the first output, this corresponds to T4.print, and T4 is basically a copy of T3. Okay. Similarly, we created T5, which is also a copy of T3. So the copy takes place correctly. Okay. The copy takes place correctly. And T5.print also gives us the same output. And here T3.print, you get the same output again. Okay. Now you can override, if you choose to override the copy constructor, you can override the copy constructor. How can you do that? So this is how you do that. The signature for the copy constructor is something like this. So again, it is a constructor, its name would be myTime, and it is a copy constructor. It takes as input or as argument an existing or reference to an existing object. Okay? So you have learned about these normal data types. You also know about pointers. There's another type in C++ that is called a reference. Okay? So how do you declare a reference type? You say something like this, myTime, and then you use the symbol ampersand. Okay? And this is some existing object MT, say for example. So this is basically the copy constructor. This is your copy constructor. Now we'll talk about this reference type some more. Okay? Now let us override this copy constructor. We have provided this declaration. Let us override it here. So this is the default constructor, and here we want to have the copy constructor. So what happens in the copy constructor? All that happens here is the member-wise copy. So we are going to assign the R's of the new object, the R's data member of the new object that we are creating. We are going to assign it the R's attribute of this object. Okay? The R's attribute of this object. So how can we access that? So we can access it directly. We can say mt.rs. Similarly, minutes, we can say mt.minutes. This is allowed in the copy constructor. You can also say get minutes, mt.getRs, mt.getMinutes. What if you don't have get functions? The copy constructor still works. It does not require get functions, public get functions. So the copy constructor has access to the private data members of this object. It has access to the private data members of this object. You can consider the copy constructor as a friend function of itself, of the myTime class. Okay? So you can consider the copy constructor as a friend function of the myTime class. What is a friend function? So again, we mentioned in our earlier discussion that a friend function is some function. It may not be a member function of a class, it may be a function outside that class, but that function has access to the private data members of a class of which it is a friend. Okay? So the friend functions, they basically in some way violate the data hiding principle, but nevertheless they are there and they make some tasks relatively easy. We'll talk about that, like where can we use the friend function. We may be using friend functions a little more in data structures, but you should consider the copy constructor has direct access to the private data members of this object. Okay? No other functions have this access. Like you cannot access the private data members of another object in any other member function. Like if you want to access the private data members of this object M2, you cannot access those data members directly. Okay? It is also like a member function of this class, and it is trying to add two objects of type myTime, but it does not have access to private data members of M2. It does not have that. The copy constructor has it. So you should remember that as well. Where is the copy constructor? Okay, here. So here again, we will say seconds is equal to mt.seconds. Yes? Okay, so this ampersand, this symbol, it basically makes empty a reference type. Now what is a reference type? A reference type means that empty has access to this object that is basically passed to it. For example, when you make a declaration like this, my time t5, and then you pass the object t3. So t3 and empty, they would refer to the same object. So in memory there would be just one object. Both T3 and MT, they would refer to the same object. MT is kind of an alias of T3. Alias, you know what is alias? Urf. So Muhammad Ali Urf, whatever. Okay? Yeah, Fazal Muhammad Urf Fazlu. Okay? So now they refer to the same person. They are two different names, but they refer to the same person. This is exactly true about reference types. So MT and T3, they refer to the same object. There is just one object. If you change, you can change that object using both MT and T3 as references. Okay? So whether you call Fazal Muhammad or whether you call Fazlu, the same person will say yes. Okay? So it is exactly the same. So it is basically an alias. MT is an alias. And here again we want to print this message. What do we want to print? We want to say the copy constructor has been invoked. Copy constructor has been invoked. Okay. So now like you will see this message getting printed, and then you'll know for sure that there is something like a copy constructor, and that copy constructor is invoked whenever you write statements like these. So whenever you assign one object to another object, the copy constructor is called. Whenever you want to create a new object based upon an existing object, the copy constructor is invoked. So here we should see 2 times the message copy constructor has been invoked printed on the screens. Okay. So if we build and run this code, okay, so what do we have here? Expected this before this. Okay, so what are we missing here? Scope resolution. So we did not do scope resolution. Okay. So here if you see the output, so you are basically invoking the default constructor, then the overloaded constructor, then the copy constructor, and the copy constructor. And we overrided the copy constructor, but we did it well, like we did not mess up with the copying process. Okay? If you are overriding the copy constructor, you should make it like, you should ensure that you have code like this there, so that the member wise copy can take place properly. Okay? The default copy constructor does that. So if you are overriding it, you should also be doing that. Understand that? G. Yes, this will also invoke copy constructor, and this will also invoke copy constructors. There is no difference. No difference as such. So this is the assignment operator. The assignment operator function kind of, so that also invokes the copy constructor. Again, the purpose of this statement and this statement is the same. Okay? So why write 2 different functions for doing the same thing? Okay? So the idea is that we have this one function, the copy constructor. If you are doing a copy like this, explicit copy, or if you are doing a copy like this, okay, both will invoke the same function. Okay? So this is basically you are optimizing things. This is more efficient that you are using invoking one function in 2 different ways. Okay? Similarly, let me drop one last point. So here, here we said in the addition, in the add function, what are we doing here? We say my time sum, and then sum dot reset, and sum dot this, and then we say return sum. Return sum. Now where does this sum go? The sum will, for example, if you are getting the sum and storing the sum in some other variable, Okay, so there too the copy constructor will be invoked. Okay, so I'll leave you at this point and you can think about it and you can use it. Like if you have this code and then you use the add function and subtract function. So other than like you might have written just these two statements, but you will be getting lots of output on the screen which will say copy constructor call, copy constructor call. So you should be able to track where did the copying take place. So whenever you are returning an object of this type, like sum is one object, okay, and this object will be copied into the object that is in the main program. So there too you will have the copy constructor invoked. So if you say something like this, for example, let us try it. If you say something like this, T1 is equal to T1 is equal to T4 dot add T5, say, okay. So here too copying takes place. How? T4 dot add, it returns you the sum object that is copied into T1. So now you should see the copy constructor has been invoked message 3 times, okay, 3 times. So these are exam questions, potential exam questions. So you should learn these things. What? जो कॉपी कंस्ट्रक्टर हमने ओवरराइड किया है वो तो हमारे पास यूजलेस है क्योंकि वो तो बिल्कुल सेम फंक्शन परफॉर्म करेगा हमारे पास. Yes. So the point is that what is the purpose of overriding the copy constructor when it is doing the same thing that the default copy constructor does? A very valid point. So I mentioned this thing about shallow copy and deep copy. Okay, we'll get into situations where the default copy constructor is not enough. It would not be able to serve our requirements. Okay, so we'll get into those situations, and then we would require to override the copy constructor and do it manually by ourselves. Okay, and that happens when you are using the heap memory, when you have objects on the heap. So those objects live separately and their addresses are stored in a pointer that lives inside your object. When you are doing copies, so just the address is copied, the object remains the same. Okay? If you want to make copies of the object as well, then you need to override the copy constructor, create a copy of that object, and then create a copy of the address as well. Something like that. Okay? So that is deep copy. So right now, copy constructor, it may not make any sense why override it. That is correct. But when we are in situations where the default copy constructor, the behavior of the default copy constructor is not enough, then we might want to override it. Okay? And we'll get into those situations many times in data structures.